Okay, hello everyone, and welcome to the third webinar in the webinar series Love Your Data. In this time, we are discussing about where to store your research data, and especially about where to store your data in the CSC environment and what kind of storage possibilities there are in the CSC environment. So of course there's many other places also to store your data than CSC, but in this webinar we are checking what kind of storage services you get if you get the CSC account, or with different CSC accounts, what kind of storage possibilities are there linked there. Talking about storage is a little bit kind of dangerous in this case, because you can think the storage in many ways, but mostly the CSC storage is linked to data management and data analysis, and not so much data preservation. But let's see what kind of services you will get for your data from CSC. So in this presentation, we are going to go through quickly three different kind of services that you can get from CSC: the high performance computing environment and the storage areas linked to that, the cPouta cloud environment, where you can set up your own servers and also your own storage systems, and the Iaas storage service, which is perhaps the most relevant for this presentation, which is intended for long-term storage of research data. There's two links here in this slide, where you can see where you can get these accounts for these services and further more detailed instructions how these tools are then used. What's common for these three services is that they are free for academic university researchers working in Finland. So if you are working in a research, doing academic research in a Finnish university, you can get access to these services by applying an account from CSC. So let's start with the high performance computing environment of CSC. So this is the as name says, it's intended for computing. So it's a data, you can see it as a data analysis environment. Of course, you can do also simulations there without any data. But the core of this HPC environment are the two massive computers of CSC, the SISU supercomputer and the Taito supercluster, which in together have nearly 60,000 computing cores to offer to you. In addition to just huge amounts of computing power, these environments also include some special tools that might be beneficial for you. For example, computing nodes with large amounts of memory, or GPU special computing units. In addition, there is a Kaivos data server linked to this environment. And what's common for this HPC computing environment is that it is quite closed environment. It is used by opening a terminal connection from your local computer to the HPC environment and then running command line Linux tools mostly. There are some graphical interfaces too, but most of the work in this environment is intended to be executed through Linux command line tools. In addition to this computing power, there is also storage environment here in the HPC environment. But the main aim of this storage environment is to support processing of your data, not for storing or sharing data sets for longer term or for wider community. Typically, the data which you have moved to SISU or Taito or have generated there, it is visible only to yourself, but you can open it, maybe your group members if they have accounts in the HPC environment of CSC, or all the other HPC environment users, but you cannot directly publish them to the internet. So this is a quite closed environment for your data. So when you get a CSC user account, you will get a few personal directories to this computing environment, which is linked to both SISU and Taito computers. First of all, you will get the home directory. Home directory is rather small. It's actually kind of just supporting your user account and using the environment. It's intended for small storing small settings and parameter files which you need to have there, or which you want to preserve all the time, but not for any big data. So 50 gigabytes is rather small. What is special is in this home directory in CSC environment is that actually one of the few places which we back up daily. So if you have there some settings or some software code which you have written and you remove it, we can return the copy of the version that was there 1 or 2 days ago or even earlier. However, the main place for your research data in the HPC environment at CSC is the work directory. So each user has his or her own work directory, which by default is 5 terabytes in size. So you can put quite massive data already there. This directory is linked directly to these SISU and Taito computers and their computing nodes, so you can quickly access the data from the or link this data nicely to the computing power, and so it's intended for data analysis, but it's not intended for having your data there for very long time. By default, files which have been not used in any way for 90 days will be automatically removed from this directory. So the idea is that you keep your data in the work directory just as long as you are actively working with that data. And then when you know that, okay, you are not going to work with the data anymore, you move the important parts, the specific input files and perhaps the important results files to some other places like the HPC archive, which I will be showing next. In addition, there in the work directory, there is a directory called Do Not Remove, where you can put datasets that you constantly need and don't want to be removed from work directory. However, please remember that there is no backup here in the work directory. And this means two things. First of all, if there's some kind of technical error at CSC which causes the data be lost, then we cannot bring it back. Well, that hasn't happened for a long time. A bigger threat for your data typically is that you or your software does something funny, removes a file or modifies a file that you would not like to be modified. And if that is done, we cannot bring the data back. There is no backup and there is no undo button which you could use if you have somehow spoiled your data there. The HPC archive is the home and work directory are shown as kind of file directories in the computing system, but the HPC archive, which is the kind of code storage place at CSC, is not visible as a directory. It's a data storage server based on Iaas system, which you use with specific Iaas commands. So here you have 2.5 terabytes of storage space where you can store data, and it is preserved there more securely than in your work directory or home directory. And it's kind of cold storage area. And what I mean with cold storage here is that you can just with this Iaas command upload a file to this environment or download a file from this environment. But while the data is there in HPC archive, you cannot modify or read it. So if you want to, if you have uploaded there a file in January and then you want to in later on check what is in the third line of this file, you have to first download the file back to your work directory and then open it there, and only after that you can study it. And if you want to modify it, you have to upload a new version of this file to HPC archive environment. This functionality, or the way how this HPC archive is used, resembles much the Iaas service environment, which I will be discussing later on. But this HPC archive is made mostly to support the usage of SISU and Taito environment, and thus it's not visible outside the CSC computing environment. So you can only upload and download files to this system from the CSC environment. There's a question that we have Horizon 2020 research collaboration in France. Who provides research data to us in TUT? is it bureaucratically possible to give our friend's collaboration an account in CSC so that he could upload the data there for us to read? The answer to this question is that it is possible. For international collaboration, you can apply for so-called international user accounts. The only limitation here is that the principal investigator of a research project must be from a Finnish university, and then this with the help of this principal investigator, typically a professor or lab head, you can then invite and add international members supporting to your project. So it is possible to do so. Okay, so let's go further in the presentation. So these three things which I previously showed you, home, work directory, and HPC archive, you will automatically get when you get the CSC account. Then you can apply for a project disk. It's a kind of special service which we don't by default provide, but in some cases you can apply for that. So the project disk can be something like few terabytes, up to maybe 50 terabytes, but preferably less. And there's two main reasons why you might need to have a project directory in Sisu and Taito environment. First of all, if your datasets are really so large that you cannot handle them in your 5 terabyte work directory, then you can apply for project disk. Another typical example is that if you have some kind of a common data in your research project, that you have, say, 3 or 4 users in the Sisu and Taito environment working with the same dataset, so we can set up a project directory which is visible to all these users, where they can kind of share the same datasets and use the same, say, input data or database for their analyses. But also in this case, the data is visible only to the HPC environment of CSC, meaning Sisu and Taito computers. And just like in the work directory, there is no backup of this data. So this is not the place to kind of have your secure copies of the data of your research group. However, unlike in the work directory, here in the project directory, we don't have the automatic cleaning on, so the data will be preserved there as long as your project is valid or before you remove it there. Then finally, the Kaivos database server. This is set up for applications and projects which need to combine the computing power of Sisu and Taito to an SQL database. In this kind of high-performance computing environment, which contains many computing nodes, it is quite difficult to set up an internal database server. Running a MySQL or PostgreSQL client is not actually technically very feasible. So to provide this kind of support to this environment, CSC hosts a Kaivos database server, which is a MariaDB service platform, which can be connected to the Sisu and Taito environment. Using Kaivos requires you to send a separate application to CSC, and we will set up the database for you. So you cannot actually yourself build a new database to this service, but you must first apply for storage space and number of databases from CSC, and we will create the kind of the framework of the database there, and you can then start adding your tables and importing the data after we have generated the database in the CSC environment. And typically this database is used by SQL tools like a MySQL client in Sisu or Taito, or some SQL interfaces in programming languages, some Python or Perl scripts which would then handle the data management. So these are the things which you have when you are working in the HPC environment of CSC. Then the IDA storage service. IDA is also this kind of cold storage service, which I already mentioned there in the case of HPC archive. So it's a place where you can put your research data in and share the data and make it available make it stored and also available for other users. However, this IDA storage service is not it's not part of the CSC computing high-performance computing environment. It's so you can use it totally independently from the Sisu and Taito computers. You don't have to have an account there to be able to use IDA. And actually, even though CSC produces the IDA service, we are just hosting it. The storage quotas are granted by the universities and Academy of Finland. So when you apply for quota, it is applied typically from the storage quota of your home university or from the Academy of Finland. So CSC just maintains this service. You can apply storage spaces up to something like even 100 terabytes, but IDA is not just storing large datasets, because through IDA you can easily make a kind of a long-term copies of your datasets, which you can share with your group members or even all the users of the internet. IDA is project-based, so those directories in HPC archive are typically your private owned directories, but IDA is in IDA you apply storage space for some research project, and it is granted to a research project, and you can have then several users using the data there, producing data and modifying it, and managing the metadata there. IDA is visible to internet, and you can connect it directly from your own laptop or with web browser. You can use web browser client and command line client, or then some graphical client software to use this service capacity here. And IDA is part of the open science program at CSC, so it's linked to other services too, like Etsin Research Data Finder. So here you can add some metadata to your dataset and also edit it or make it visible to more sophisticated data analysis tools. Then the third part is the cPouta cloud environment. So cPouta is the Iaas cloud environment of CSC. What does that mean? It means that if you get an cPouta account and project, you can log into the cPouta system of CSC and launch your own virtual machine, which you can manage like it would be your local server. So you can, while in HPC environment you are quite limited, you are only a user, you cannot define exactly what kind of operating system and what kind of servers they are running. But here in cPouta, when you launch a virtual machine, you can do whatever sysadmin could do in a normal server. In addition to launching virtual machines in cPouta, you can also use data volumes. Data volumes are kind of you could think them as virtual USB hard drives, which you can plug on in one virtual machine at a time. And typically your project will be granted the storage quota, and which is something like 1 to 50 terabytes. And from this storage quota, you can then define data volumes with different sizes. So a project can have several data volumes, and you can create new ones and delete old ones during the project. Creating virtual machines and managing data volumes may sound quite difficult, but actually most of the management stuff can be done through the web interface of CSC of cPouta. So it's fairly you can fairly easily actually create a own virtual machine and link your own data volume to this virtual machine. And once you have this kind of system working, you can then using your virtual machine copy or generate data to your data volume to be further analyzed or used in this cPouta environment. What's nice in using the data volumes is that data volumes are preserved even though you would close the virtual machine which you used to feed in the data to the volume. So just like the external hard drives at home, you can have the hard drive even though your normal laptop would be broken or you would switch it to a new one. So when you then later on launch a new virtual machine, if you have a data volume that is not linked to any other machine, you can plug it to this new virtual machine, and this new virtual machine can still see the data which was previously stored to this data volume. So this is quite like a kind of a data directory which you can switch from one place to another. However, in cPouta, the resources are also project specific. So if you create a data volume in cPouta and you have a project member there in the same cPouta project, the other project member can later on also use the same volume or even destroy it or delete it if you want it, or do whatever. So the virtual machines and the data volumes in cPouta environment are owned by the research project, not single users. The volumes are preserved there in the cPouta environment as long as you keep them there. So you can create new ones and delete old ones. And of course, if you delete the volume, the data in the volume is lost. And also here you should remember that there is no backup for the volumes by CSC. So if you want to somehow secure copy the data in a data volume in cPouta, you have to take care about that yourself. Create another data volume or have a copy of the data in IDA or HPC archive or somewhere else. So if the data volume is for some reason lost or accidentally destroyed or otherwise broken, there is no backup copy of the data available at CSC or in the cPouta environment. Only if you make the backup yourself, the data will be preserved. Now, as in cPouta, you are hosting your own virtual machine. You are not limited by the restrictions of the CSC high performance computing environment, and that allows you to kind of develop your own data management or sharing environment here to cPouta. You can install, for example, IDA client to your virtual machine to import and export data from IDA. You can run there an SQL server and generate it totally freely. You don't have to ask permission from CSC to set up a SQL server there. And you can even set up a web server to your virtual machine to provide some kind of data service to public internet. And actually, you can even mount work directory or home directory from CSC computing environment to your cPouta, to your virtual machine running in cPouta. When you are using these services, which are not local ones, you of course have to transport somehow your data between these places. So to HPC archive, well, in the case of IDA, it is quite clear. IDA has its own client tools and commands which you use to move data between your local computer and IDA. But in case of HPC archive and cPouta, you have to somehow move the data between your local computer and CSC environment. The tools which are available are the traditional command line tools like SCP and rsync. But in addition, there are graphical interfaces, web-based or separate client software like FileZilla or WinSCP, which you can install locally and then have a kind of graphical data transport connection between CSC and your local computer. But you can also try to use remote disk mounts like SSHFS or OSX Fuse or Dokkan. And you should note that when you are using CSC HPC environment or a server running in cPouta, you can quite often, what is reasonable quite often is to download, for example, from internet the data directly to the server or service of CSC and not put the data first to your local computer and then only push it to CSC environment. So you can use direct download commands from web like wget or curl, and there are data transport tools like rsync or gridftp, which you can use to duplicate some dataset from a public repository in the internet to CSC environment. And also there's a direct connection between IDA and CSC HPC environment, so you can also bring data back from IDA quite easily to the CSC environment. And if you compare these things, so in IDA and cPouta, you can make the data public but in HPC environment, it's mostly visible only to the HPC environment of CSC. When you are playing with these disk areas and storage places, you are often concerned about how much storage space you have there. But one issue which you should take account when you are planning how to use these things is the data transfer rates and how to get your data there and back if needed. Well, it's not a clear case how it goes. Here in the table which is shown here, there are just kind of sample cases of data transport speeds and how things go. So this is not a kind of a very detailed study. I just tried last week to play a little bit with the human genome, a faster formatted human genome file, which the size of human genome as a compressed gzip is about 1 gigabyte, and how quickly I can do some things with that. So if I would download I download data from the EBI that is located in England, and if I download it directly to Taito or a virtual machine running in cPouta, it takes, well, in cPouta half a minute, in Taito a few minutes. I think these values may be very dependent of the time of the day when I'm doing that. And in the case of 1 gigabyte file, it's not a kind of issue. It comes fairly quickly, so it doesn't require planning. And then when I download it to my home laptop through my home ASDL connection, I start noticing that, okay, it's a little bit slower. It takes 45 minutes to get this 1 gigabyte file from UK to my home laptop. Well, this is not an issue as long as the files are small ones, but then in the last column in this table, I have the kind of scaled time that, okay, if my data set would be 1 terabyte, how long would it take? So now you can see that the difference is quite big. I could get the same 1 terabyte downloaded to cPouta in half a day, but to my home computer it would take 1 month to get the data. Then if I compare it to moving the data, for example, inside Taito, it is much faster. Moving 1 terabyte in Taito would take, from one directory to another, would take 50 minutes. So one thing to point out here is that, okay, for small data sets, you don't have to worry too much about these things. 3 seconds in copying the data inside Taito to a project directory is not an issue, but it is starting to be more and more typical that you have big data sets which you want to use in different environments. So then these data transfer times start mattering. So 50 minutes time in Taito environment is also already something which is good to take account when you are planning how you are moving your data or storing your data. Another issue here is that if you compare the situation between my home computer and CSC, you can see that the connections from the internet are much faster there. So if you are planning to manage or analyze large data sets from internet, it might be wiser to first bring the data to CSC environment, to cPouta or Taito environment, and do some preliminary analysis there, and then only bring the kind of most essential part or kind of refined part of the data to your local environment, even though you would do the final data analysis in your local environment. Another example here is that how important it is to compress your data. The faster formatted human genome is a kind of extreme example of compressibility. When I uncompress the file, it is nearly 50 gigabytes, so it's nearly 50 times smaller file as compressed file as it is as an expanded file, which means that of course the transport rate is also 50 times faster in practice. So if I would download this file to Taito as a kind of uncompressed format, it would take something like a little bit more than 3 hours. While now in this example I used only 4 minutes to download the data and then another 6 minutes to uncompress the data, and did the same task in just 10 minutes. So, common features about managing data at CSC. First of all, when you are using the CSC, you should remember that when you get an account and set up a computing project, these projects and accounts have a duration, and the services are available as long as your account and project are valid. So you need to extend your project, and if you know that you are going to move outside from university, you should prepare your data somehow if you want to preserve it. So the data will be stored a little bit longer than your project, but anyhow it is kind of directly available only as long as your account and project are valid. The HPC environment and data there is account specific, and this means that it's kind of your personal data which you have in work directory, in your home directory, and your HPC archive directory. And let's say that you are first working in the University of Jyväskylä, works with some data, and then you move to Turku to work with the University of Turku. Then you will still have all your files and data there available for you because they are your personal data. But if you are in the same time using project quota in IDA from the University of Jyväskylä and member of the cPouta project of your Jyväskylä lab, and then you leave this laboratory and project, then you don't have the access to the data anymore, even though you have yourself uploaded the data to this environment. So the data is owned by the project and not the one specific user in that case. In most of these tools which I've been discussing here, the usage and management of data is based on the Linux command line. So there are some graphical interfaces, but mostly it is that you type commands and use those to move, manage, and check your data files. In most cases, there is no backup and no undo option, so you must work carefully and take that in account when you plan how you are working. So make sure that you have some kind of secure copy somewhere about your most important data files, especially when you are working in the, say, work directory environment of CSC. Also, in general, there's no kind of automatic data management tools available in the CSC environment, especially in the SPC archive and in cPouta. In IDA, you have more sophisticated environment where you can generate metadata and do other kind of things, make your data visible. But in HPC archive and Pouta, it's quite raw platform where you then build the environment you want to use. And the data that you put to this environment can be technically anything. So we don't have in most cases we don't have any kind of predefined environments for specific data types. It is just plain disk area where you can put any data you would like to put. But of course, you should take account that there might be some legal restrictions linked to your data which don't allow you to put them into this environment. So, for example, you should not work with the sensitive human data in the SPC environment of CSC. So as a summary for this presentation, I would like to say that the SPC environment and cPouta, they are intended for working with your data analysis and extracting new information from your data, but not preserving the data. IDA is a better storage for sharing and preserving your data. The entry point of IDA is here, and as I mentioned several times, most of the stuff is done in Linux environment, and as you may need to build your data management environment yourself, so learning programming and Linux skills would be very beneficial if you want to use the services of CSC. And we are arranging courses related to these issues constantly, so please check the training pages of CSC and try to locate if you would find a course that would suit to your needs there, so that you can better start using these services that are provided by CSC. So this was one of the 3 webinars, and next week we are going to have the fourth webinar, telling how you can share and publish your research data. And for more information, please check the CSC web pages. This webinar will be added there to the YouTube channel of CSC, and all questions which you don't ask now, you can then send them to service desk CSCFI. Thank you. So if there is any questions? The question is that are the cPouta volume storage and the Taito project storage, can they be the same? No, cPouta and Taito are different systems, so they are not directly visible to each other. You can make some areas from Taito visible to from Taito visible to cPouta virtual machine through SSHFS, but it's not the kind of standard default thing to do. So they are totally different areas. If you think that HPC archive and data in HPC archive and Taito and work directory are one thing, and then cPouta environment is another thing. Yes. Then there's a question that about Ida upgrade. So yes, Ida will be upgraded in the beginning of next year, and I think we will announce more information about the technical details about that later on. I don't have more specific information about how Ida will be changed, but I think you will be provided this information later on once we are moving to the new version of Ida. But anyhow, all the data will be preserved there, so that you don't have to worry about. But there might be some changes how the system is used, but I'm not actually expert on that, so you will get more information from other channels about that. And then another question about long-term archival support bus. Yes, that's also Ida-related stuff, and unfortunately, I don't know too much about what's happening there, which doesn't mean that it isn't happening. I think that we have experts working on that, but I don't have personally information what is going to happen there. Okay. If there's not any other questions, I think we can then stop. Thank you very much for your attention.